When building a React app, you need to transform JSX and TypeScript into browser-ready JavaScript, serve it during development, and bundle it for production. Vite is one of the more popular solutions for handling this. Vite is a front-end build tool with two main parts. One, a dev server that serves your front-end code to the browser for local development. Two, a build command you can use to bundle your code so it is ready to host. When developing your application locally, you need a tool to actually send your code to your browser when you click around on your local app. If you are developing a React application which has TypeScript files, JSX, separate CSS files used by these components, etc., these files cannot be natively read by your browser, so you need a way to transform the code into something the browser can work with and then serve it. This is the development server part of Vite. The Vite dev server takes advantage of two recent developments: native ES module support by browsers, and tooling written in compile to native languages like Go or Rust. Firstly, Vite skips the bundling step of a tool like Webpack, and instead serves your site to the browser through native ES modules. If you have used React, you're probably familiar with ES modules. This is the format for sharing pieces of JavaScript code across files, and it allows you to reuse React components and functions. It used to be ES modules were not natively supported in the browser. ES module support was only specified as part of JavaScript in the release of ES 2015, and it took major browsers as well as Node.js several years to fully support it. On the back end, however, Node had already adopted CommonJS and the require syntax as a way of addressing this problem. So, how could you utilize ES modules in React if browsers didn't fully support it? A common solution was to use a bundler such as Webpack. The bundler would process the JavaScript modules and transform them into files called bundles that can be read by the browser. It builds a dependency graph of the application to explore which files are dependencies of others, for example, React components that use other components or CSS files. Webpack processes and combines these separate JavaScript files into different bundles that are sent to the front end, and the Webpack runtime orchestrates their interaction, allowing different pieces of JavaScript to use different modules in the browser. This works, but there's an issue. If you have thousands of JavaScript modules, which is not unrealistic for modern JavaScript applications, when working locally, anytime you change a file, the bundler will have to go through the rebundling process for the module you changed, as well as any module that imports it. When starting up a dev server, every module has to be bundled. This can result in long startup times on large applications. Instead, Vite takes advantage of the nascent ES module support in most browsers to skip the bundling step. In addition, when serving your code, it uses some optimizations to make things more efficient. It divides your code between the source code and the dependencies. The dependencies are JavaScript files that do not change during development. For example, the stuff in your package.json, and can be quite large like component libraries. Vite pre-bundles these dependencies using ESBuild, a bundler written in Golang that is 10 through 100 times faster than JavaScript bundlers. The dependency pre-bundling does the following: converts CommonJS or UMD syntax to ES modules, since all Vite code is served as native ESM. It also converts ES modules with many internal modules into a single module. For example, Lodash.ES has over 600 internal modules, so when we do import debounce from Lodash.ES, the browser will fire off over 600 HTTP requests, even if we just need one function. Meanwhile, our source code, for example JavaScript, JSX, and React components, is served as ES modules directly to the browser. With route-based code splitting, only modules for that particular route are sent to the browser. Vite also offers hot module replacement over these ES modules. This means that when a change is made to these modules, only those specific modules are replaced, and the application state is preserved. So, do Vite's optimizations actually make local development faster? Vite's documentation claims so, but real-life tests on the subject vary. TurboPack, a similar tool to Webpack except written in Rust, claims to be faster than Vite in development, as does RSPack. Speed is the reason Vite claims they use this native ES modules approach in their documentation, but the truth is a bit more complex. It's also important to note, these design changes Vite makes in its dev server are distinct from its step for creating a production build. Vite still uses a bundler, rollup, for creating your production site, since there are further optimizations that can be made during that step. We can see the process through which Vite serves your file in a local environment, but how does Vite work for production builds? Well, to build your site, all you need to do is run the Vite build command, which will produce code that can be hosted in a static hosting service. That poses the question though, why bundle for production if ES module support makes it so we don't have to? ES modules make it quicker for your local server to start up because it skips the bundling process, but bundling still has advantages for hosting on prod. ES modules are less efficient due to additional network round trips caused by nested imports. Bundlers also utilize tree shaking, lazy loading, and common chunk splitting to further make your app more efficient. Vite uses rollup for bundling, although it uses ESBuild for pre-dependency bundling, which is considerably faster. Rollup offers a more flexible plugin API. That being said, there is an active ongoing effort to build a Rust port of Rollup called Rolldown, which might eventually make its way into Vite. Another big reason that developers use Vite is for convenience, especially for web applications built with libraries such as Vue or React. One of the earlier methods of creating React SPAs was using the CLI Create React app. This solution was built on top of Webpack, and changing the configuration of Webpack was complicated and tedious, especially for newer devs. Vite instead makes things more convenient, and there are a plethora of community-maintained templates for bootstrapping an application quickly. These include templates in React, Vue, Svelte, Solid, Electron, and many more. So, what other solutions exist in the front-end world? For a more opinionated solution, the official React docs recommend using Next.js, React Router 7, Expo, Tanstack Start, or Redwood.js. React Router 7, Tanstack Start, and Redwood.js are all built on top of Vite. Next.js, however, uses their own bundler, TurboPack. As it stands now, however, Vite is quickly becoming the default for creating client-side web applications, especially in the React ecosystem.